Okay, today we are learning GCF. GCF, GCF means greatest common factor. Okay, so we need to check in two numbers which is the greatest common factor. That is how we do GCF. That is called GCF. Like two numbers, we can say any number. Like let's say that's like 12 and 18 if we take. Okay, so we need we will check a list of factors that we get from 12. List of factors. Factors means it will divide with how many numbers. So 12 can be divided by 1, 12 can divide by 2, 12 can divide by 3, 12 can divide by 4, yes, 12 cannot divide it by 5, and 12 can divide it by 6. So 1, 2, 3, 4, 5. Total 5 factors we get from here. Now list of factors in, we will check list of factors in 18. Okay, so in 18 you will find 1 is divisible, 2 we can divide that with 2 also, 3 we can, yes, 4 yes, and 5 no, 6 yes, 7 no, 8 we can, and 9 we can, right? So greatest common factor, in here you will see common, which is the greatest common factor. This is the last greatest here, and this is the last greatest, I mean this is common in both of them. So here we can say greatest common factor is equal to 6. As you can see here and here, this is common in both, so this is called GCF. Okay, one other way for these to do that is GCF is we will take LCM for both. Like I will write 12, 12 2 ones are 2 6 are 12, then I will divide by again 2 and it will come 3, then I divide it by 3 and it become 1. So this is the first factor I get from 12 is 2 multiplied by 2 multiplied by 3. Now I need to check from 18 what is the factor coming up. If I write 18 and divide by 2, it becomes 9. Then I have to divide by 3, it becomes 3. Then divided by 3, it becomes 1. So I get 3 factors, 2 multiply 3 multiply by 3. As you can see in here, this 2 and 3 is common. The others are not common. So 2 multiplied by 3, as we can see, 2 multiplied by 3 is equal to 6. So this is GCF. Okay. And this method called prime factorization. Prime factorization. Okay. So, and that one is normal. Okay. As you can see, GCF greater common factorization, greatest common factor. Okay, so we have another question. If you can solve them, I mean, I solve one, you can try this if you want. Like 20 and 30, what would be the factorization of this, and what is the GCF of this? Okay, so our next question is what is the GCF of this 20 and 30? As you can see, I show you before. Like we will first write list of factors. List of factors. Okay. List of factor in 20 and list of factor in 30. Okay. as you can see, 20 can be divided by 1, also can be divided by 2, also 20 can divided by not 3, 4, yes, what else, 20 can divided by 5, and 20 can divided by not 6, not 7, not 8, not 9, 10. Okay, now we will check in 30. 30 can be divided by 1, 2 can be divided by not 4, 5, yes, can be divided by what else, 10, and what else, 15, yes. So 10 and 10, this is the 10 is equal to GCF of 20 and 30. So this is that is simple method. Okay, the other method is a prime factorization. So the other method we will do as I explained to you. Okay, so here we will calculate first 20 and then 30. 20, 2, ones are 2 and 0 down. Then again with 2, with 5 common, then again 5 and 1 common. So for 20 we get for 20 we get for 20 we get 1 2 3, 2 multiplied by 5 multiplied by 2. Now we can upside down, it's okay. Again we will check with 30, 32, 15, then with 5, 3, then with 3, 1. So it will come, 30 will come 2 multiplied by 5 multiplied by 3. See, these two are common. So we can say common prime factor is 2 multiplied by 3, which is 6. We can say GCF is equal to 6. Answer. Okay, so this third method would be way easier for you, and I think it is easy for me also. So let's try this one. In first question, we have question number 1, QCF of 12 and 18. We will do one LCM in here, like 12 and 18. So first we will divide with 2. We will see which is divided, which can be divided, least divided. 2, 6 and 9. And if we divide again with 2, 9 cannot be divided with 2, we will try with 3. Okay, if we divide with 3, it will come 2 and it will come 3. So we cannot factor more than that. So the answer would be, we need to multiply these two. So QCF is equal to QCF of 12 and 8 is equal to 2 multiply 3, which is 6. Same as that second question, QCF of 20 and 30. If we factor like that, 20 and 30, we will divide first the least amount, like we will divide it by 2, 10 and what else, 15, yes. So we will divide again by 5 because it cannot divide anything else right now. It will become 2 and 3. So we can say QCF of 20 and 30 is equal to 2 multiplied by 5. These two will be multiplied. So it will come 10. So QCF would be 10. So this is the more easy method. There is 3 method I show you. Whichever you like would be okay for understanding this. And there is some real life example for that. Like you want to make square tiles from a piece of cloth that 20 inch and by 30 inch. And what is the largest square tile that you can cut without wasting any cloth? Like something easy to organize. If, if you do with 20 by 30, you have to cut 10 inches from one side, 30 side, you will get a square like 20 by 20. So this GCF help you to cut and divide things equally when working on projects. Okay, so here is one question like there are 20 boys and 36 girls in your class. You want to divide equal teams with the same number of boys and girls on each team. Okay, so with GCF, if you find with GCF, number of boys is 28, number of girls is 36. Okay, so when you do with GCF, okay, we will get 14 and 18, then we will divide again with 2, it will come 17 and 9. We cannot divide any further. So we will get 2 multiplied by 2, which is 4. So we will make 4 teams, and each team, like you can divide this, each team will get 7 boys and 9 girls. So that is how it helps. Like it helps you organize group in teams in school. Yeah, I hope you get it. Like if I divide 28 by 4, it will come 7. So 7 boys and 36 divided by 4, 9 and 9 girls. Okay, so if there is anything you want to share or if anything you did not understand, please comment and I will try better next time. Thank you.